Good morning, my lovely Niners. Right, buddies, today we are starting a brand new unit, which is only, unfortunately, a couple of lessons long, but it is a really, really cool unit nonetheless. So in your book, please put the title Bearings. Now, all that you're going to need for this lesson is a ruler and a protractor. So the math set that you've been using all along in our constructions unit will do nicely here as well. But this time we don't need the compass. We actually just need the protractor. Because actually, this unit's about a different type of compass. How exciting! Okay, cool. So to start with, bearings, my lovelies, are a way of giving directions really, 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 really accurately. So if I was to say a direction to you, say that you were, I don't know, like say you were the captain of a fishing vessel or something like that, like this picture up here, and you wanted to get somewhere, but you didn't, well, you needed to get directions to get somewhere. Well, there's not much to look at out at sea, like there's not very many landmarks if you're out in the ocean, it's just a bunch of ocean. So how do you know which way you're going? Well, you'd use a compass. And say you were going to go a big distance, it's not really enough just to say, I'm going to go west. You've got to be able to say, a lot more accurately than that. So let's say that you were going to go from, I don't know, like Ireland or something, and you're going to go to North America. Well, maybe you were aiming for New York, but you might actually end up in the north of Canada, or you might end up down in Florida, or you might end up anywhere if you're not 100% accurate in what direction you're going over such a big distance. And that's what bearings are for. Now, if you know how to do bearings and if you know how to use a compass, I put this picture down here just because I want you guys, I hope that you guys are taking DAV, and if not, I hope you at least have a little bit of interest in that kind of thing. You can use a compass bearing actually just in real life. So this is just a picture in England of someone using their compass to figure out where they are. Like this person's found a trig point there and they're using their compass to navigate. This is an old-fashioned compass, and if you look at it really close, see where it says north? See all these little numbers? See it says north, and above it's the 0? All of these numbers around the whole outside are for the bearings, so it's kind of neat. Yeah, so that's enough of that. So here's what I'm going to get you to do. I want you just to draw for me just a little compass kind of point like this, a little compass star, compass rose, or just up left and right arrow is cool. Now, in case you don't know your directions, you do have to know them. It's never eat shredded wheat, and it goes clockwise around from the top. Now, here we go, buddies. To start with, I'm just going to explain to you really what a bearing is. It's a way of assigning a number to a direction, and that's it, okay? So here's what we're going to do. North, so going straight up north, is actually the first number we start at. So it's going to be 0. Oops, I've drawn that poorly. That's going to be 0 degrees, north is, because it's like, I don't know, it's the number you start at. Now, if you start at north and you start kind of measuring directions along this way, how many degrees will you have got to by the time you get to east? Well, if you said 90 degrees, you're absolutely right, because it's made a right angle. What if we carry on then from north all the way down to here? Now we're pointing exactly the other way. So how many degrees is south? Well, 90 more. So 180 is 180 degrees. It's the opposite direction. Okay, keep going, buddies. By the time you get to west, how many degrees have we turned? Well, if you said 270, because it's 90 more again, you're absolutely right. And then say you were to finish up and go all the way back to north again. Well, it is 0 degrees, we already know that, but it's also 360 degrees, because by the time you've turned 360 degrees, it's the same as having turned not at all, if that makes sense. If you were pointing with your hand forward, and I told you to start spinning your body 360 degrees, you'd end up pointing in the same direction, right? So 360 and 0 match up with one another because they both mean that you're pointed the same direction that you started with, and that's pretty much how it works. So if I said to you, draw me a bearing of, I don't know, 30 degrees, it would look something like this. You know 0's north, so you'd go 30 degrees. It would be like that. That would be a bearing of 30 degrees. Get me, buddies? And say I told you instead to draw a bearing of 200 degrees. Well, again, you start at north and you spin all the way around. That's 90. Keep going, 180. 270 is too far, so it would be down like this. That, buddies, would be a bearing of 200 degrees, and the angle's actually this. It's that great big reflex angle down there, 200 degrees. So I hope that you kind of have your head around the basics then of what a bearing is. It's just a way to, instead of using words like north, south, east, west, or northeast, or northwest, or even in geography, there's things like north, northwest, and north and south. Yeah, oh my gosh, yeah, there's lots of different ways of saying it, but it's yeah, mathematically perfect, and this really supports geography because I know you learn it there as well, and certainly in DV too. Okay, on to the maths. Let's do it. Okay, question one. Here's what we got. Question one says this. It says, find the bearing of A to B. Now, you should be, look at this, my lovelies. This took me a long time to figure out how to make this protractor, so I hope it's exciting. I hope you're excited about it. Okay, find the bearing of A to B. Here is how you do these questions. If we want the bearing from A to B, where are we stood, buddies? Well, if you said A, you're absolutely right. So if we're going to start from A and find the bearing to B, it means that we're on A. Here's how you do it, and I think you might just have to watch, so I don't know if you can copy this perfectly this time, but here's what you're going to do. Step one is you get your ruler out, which I'm going to have to use the shape tool for, and what you're going to do with your ruler is you're just going to draw the little compass thingy on top of the A, and it doesn't, yeah, as long as it's just perfectly horizontal, that'd be perfect. And then again, the other way, insert, shape. It's a bit fiddly on the computer. It's not too bad for you guys, I don't think, though. Shape, line. Okay, here we go. And boom. Now I'm going to have to adjust those because they're not quite right, but that's all right. Okay, there we are. Perfect. I'm happy with it now. Okay, super duper. Happy with that, buddies? All we did, we drew the little star on it. And here's what you're going to do. Step one, use your ruler, and you're going to connect A to B. So using your ruler, here we go. Connect A up to B, shaboosh, like that. I'm going to try to make the line a different color. Let's make it black, and let's make it thick, bigger, 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 bigger. Oh yeah, okay. So there's the line that we're on about, okay? If you want to get the bearing of it, the bearing, my lovelies, don't forget, is like this. North at the top is 0 degrees, okay? So the bearing is actually just this angle here. Do you get me, buddies? That it's that angle there. So how are you going to measure that angle? Well, with your protractor, of course. And this is going to be tricky too, but I'm still going to try. Here we go. Pop your protractor. Oh, this is working so good. I'm so happy. I'm proud of myself, my lovelies. Okay. Oh, nearly I'm proud of myself anyway. So line it up perfect so that the targety part, see the target part here? Let the target part go right there. Make this vertical line go straight over top of the blue line that I drew for north. And the other one perfectly aligned as well. I think it's snapping to grid, so I think that's as close as I can get. So we'll just have to take the... Oh, there, we got it, nailed it. Okay, and here we go. To get the back line, here's what you're going to do. Starting off, look at the top of the protractor. Can you see that the 0 is on the outside, not the inside? Yeah? 0 is the outside number, not the inside number. That means we're using the outside numbers. So then you just go down to where the protractor is. Looks to me like it's about 132.5, but I know that I'm a little bit misaligned on one of my things, so I'm just going to round it a bit with a good, clever guess, and I'm going to call it 132 degrees. So I think that this is at 132 degrees because I looked right here. I looked right there, and I got that it was 132 degrees. So what's the bearing of A to B? Well, it's 132 degrees. Cool beans, buddy buddies. And that's it. That's all you got to do. So the answer to this question is 132 degrees. Cool. Find the bearing then of B to A. Well, here's the thing. People always are kind of the attitude that it's going to be the same because it's kind of like the same but backwards. People are going to think it's the same, but it's not actually. So here's what we're going to do. Start again by whacking your ruler and making a lovely compass point on top of B, my buddies. So here we go, little compass star on top of B, and there we go. North, of course, is straight up, and I don't often label the other ones on it, but never eat shredded wheat in case you wanted to. And this time our bearing is actually going to be a bit different. This time our bearing, my lovelies, and I'll switch colors. Do this one in green, I guess, our bearing is going to be all the way around to there. Because don't forget, it always has to start at north, and it's always got to go all the way around till it hits the line. So we're looking for a really big angle here. Now, looking at your protractor, you're not going to be able to measure that because they're not a 360-degree protractor, even though some of you might own a 360 protractor. Most people don't. Most people have these little 180 ones like this. And yeah, so that's what we're going to get. So here's what my plan is, buddies. I'm going to measure the part of the angle that is not given. So I'm going to measure everything that's not green, and then I'm going to use maths to sort the rest of it out. So laying your compass down, get it in just a position. So there we go. Oh, perfect that time. Now, here we go, buddies. The part that's not in green is this. Well, the zero's on the inside this time, so it's zero's on the inside. We're going to come all the way up here. It's going to be, I think, about 48.5. I'm going to call it 48, though. So I'm going to call that angle right there 48 degrees because I've read it from right, here it is. I've read it from right there, okay? And I knew it was with the 50, so it's like 48. So 48 degrees is what I think that is. So move the protractor out of the way, and here we go, 48 degrees. Bang. Well then, buddies, what's the remaining angle? How are we going to get it? Well, if you said you're going to get the green one by just taking that away from 360, you're absolutely right. So it's going to be 360, take away 48, and what are we going to get when you do that, my buddies? Well, oh yeah, and you get it was 360 because that's all the way around. Well, 360 take away 48, 5, 10, 2, 4, 1, 12, 3, 312. Oh my gosh, that's what we've got. 312 degrees. And that is your answer, buddies. Cool? Get the idea of how this works? Yeah, you just have to know where you're starting, where you're going, and you have to remember that you're measuring from north, and just do any maths you like with it. Cool. One step harder. Here we go. This one here, my buddies, is a lighthouse, is 80 meters from a ship, and it's on a bearing of 220 degrees. It says use a map scale, and so this is something you can actually do, so you should almost pause and do it without me in a minute. It says use a map scale of 1 centimeter is 20 meters, and accurately draw the lighthouse and the ship in the correct relative position to each other. So yeah, here we go, buddies. First things first is I'm going to cheat a little bit. There's a lighthouse and a ship. A lighthouse is 80 meters from a ship. So what are we on to start with, my lovelies? Are we on the lighthouse or are we on the ship? So it could be in either. A lighthouse is 80 meters from the ship. So we're on the ship, okay? Now, I'm going to cheat because I don't want to make my picture look too messy, but it gives us a bearing of 220 degrees, and I know that that's going to be down and left because I've kind of got my directions memorized a little bit. So step one is I'm going to mark my ship here, and you should mark your ship as well, and I'm going to call it S because it suggested I should call it S. Now, it says then also that the lighthouse is 80 meters away, and it's at a bearing of 220. So number one, I can't remember what I've got in the cut and paste. Oh yeah, I've still got them, nice. Step one is let's get the bearing in. So rulers to make yourself a lovely compass point thing over top of that. You know that north is at the top because north is always at the top. Oops, because north is always at the top. And you know also that your angle that you're after is 220 degrees. Now, if it's 220 degrees, here's what I would suggest. You got to measure from north, and from there to there is how many degrees? Well, 180, you're right. So to get to 220, how many more do I need? Well, 220, take 180, we need 40 more, don't we? Cool beans, buddies? So all I'm going to measure with my protractor then is the 40 extra degrees that I need. So let's get the protractor ready, vertically up and down. So I've got my 180 already by going to here, and I need 40 more. The zero's on the outside, which is a result, so we're going to measure 40 more, which is going to be here, and you whack a little mark there so that you can see. That's the end of the protractor now, so we'll put him away for a minute, and we got to figure out the map scale. It was 80 meters away, So if it's 80 meters away, if 1 centimeter is 20 meters, well, what are we going to get then for 80 meters? Well, what do you times by? Well, that's it, 4. Happy days. So that means we are going to have 4 centimeters being 80 meters. You don't have to show workings out for any of this either, buddies, I hasten to say. It's just I'm trying to make it really clear for everybody. Now, this is going to be hard with PowerPoint, but here we go. Okay, there's 4. Oh my god, you can't, the luck of that. Did you see how perfect I got that in the first go? I'm impressed. Hey. Okay, I'm going to cut and paste one of these. I'm quite lazy like that. And we will draw our picture on. Here's the big challenge. See if I can make it match now too. Okay, so now we're just going to draw our line on such that it's exactly 4 centimeters. Black, and make it big so we can see it. Wait. There you go. Let's go 3 point. And boom, buddies. That means because this here was 80 meters. Where's draw? Draw. Because this was 80 meters. And that was altogether 220 degrees. So altogether, from here all the way to there is 220 degrees. It means for sure, my buddies, our lighthouse is there. Cool beans? So that's it, my buddies. There's the lighthouse, just there, with the light on it and everything. Boom, 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 boom. Cool. So there you go. That's it. Now, all I'm going to get you guys to do for the rest of the lesson, because now you've drawn this one with me, my buddies, you've drawn this one, and you have watched me do the first one. I hope you get the idea, and here's an activity I'm going to get you guys to do. And it's not just this, it's not just 2 questions. I think there's about, I don't know, 10 questions or something, but it's attached to the Show My Homework, what I want you to do, and you just have to use your ruler and your compass and stuff like that in order to make this work. So I'll do the first one with you just really quick. So it's just it's to find the buried treasure. It's to find a treasure, and here we go. It says start at the school. That's step 1. Done. There's the school. Okay. Next thing. It says travel on a bearing of 132 degrees for a distance of 1 kilometer. Okay. Here we go. Let's grab this and this because I forgot to cut and paste them. So here they are. Badoosh. There they are. And yeah, we want to go 132 degrees. So here's what you're going to do. Because you have a ruler, it's going to be quicker for you. I'm going to give up on accuracy now because I think I've already shown you it accurately. You draw your compass star like that, your little compass point. There's north right there in the school. And 132 degrees, protractor, spin it around like this. 132 degrees as measured from north is going to be like, and this is not going to be perfect, don't forget, 132 degrees because I'm not measured at 100% right, is there, 132 degrees. Go beans. So that's the compass part done. Or, I mean, the protractor part done. Now it says travel on a bearing of 132 degrees for a distance of approximately 1 kilometer. Now, 1 kilometer then, my buddies, is 10 centimeters. So, well, yeah, so my ruler, because it's all subjective, is not going to be okay here because like this is printed off on A4 paper, so the scale kind of depends on that. But yeah, so I can't use my ruler unfortunately, so I guess I'll just have to say you'll have to trust me. Here's what you're going to do. Well, 1 kilometer then, that's going to equal 10 centimeters. So on your page, you're going to start from this, you're going to go through the bearing to exactly 10 centimeters. There we go, there's 8 centimeters, 9 centimeters, and 10 centimeters. Oh gosh, I end up there at the restaurant thing. Cool beans, or I guess it's a shop it says. But yeah, I end up there, and that's step 1. Now you'll follow all the other steps, and you'll try to get between the buildings. Use the map scale, so don't forget that 10 centimeters is 1 kilometer, and use your protractor really carefully. All I want you to do is to take a picture of you having found the treasure at the end of this. I don't think it's going to take you ages and ages and ages, but it should be still really fun and really good. And so that's it from me, my buddies. Keep up that awesome work. Show me a nice picture of it when it's all done. And that's it from me. See you next time, buddies. Bye, buddies.